Hello, and welcome to the presentation for my Engineering Design for Innovation idea. I'm John, I'm on the Engineering Smart Systems unit, and my student number is 17080245. I'll mention now that all of the articles, images, materials, and parts included in this presentation are all referenced on the last slide. This idea, I've been working on it for a few weeks now, and I'm genuinely relieved and looking forward to sharing it with someone. So I won't waste any more time, I'll just start the presentation. Thank you. So I start my presentation with a question. Where are we going? Now it might seem a bit irrelevant or strange to have a picture of the Earth underneath this question, but the electronic device that I'm going to introduce you today has actually got nothing to do with space travel. A picture of the Earth is underneath the question because it is in fact the answer. Every single day, millions of people move to new countries and new terrains to visit millions of other people speaking thousands of other languages. People do a lot of moving around. Now, it could be for so many different reasons, such as leisure, business, asylum seeking, immigration, or just out of sheer curiosity. But what all of this accumulates to is millions of people every single day finding themselves in a place where they are not familiar with the language. So to further stress the point that I'm trying to make, I'll tell you some facts that you might not know. There are 272 million international migrants in the world, meaning that 272 million people have moved to a country that they are not from, which may well have a different language to what their natural tongue is. 6 million people fly somewhere every day. If you think about that, that's 0.1% almost of the world population get on a plane and move thousands of miles away every single day. And there are 82.4 million forcibly displaced people worldwide, usually coming from areas of conflict, very often having lived in this conflict for most of their life and never receiving the education that they need to prepare themselves to move to these new countries. If you consider how many people need to speak a different language that they might not be so familiar with every single day, the resources that we have, like education and human translators, does not meet the demand. I see this as a gap in the market for a new type of translator. So I'll share with you what I've currently found on the market. This was the top choice, most bought item on Amazon.co.uk, which is the Vasco M3, retailing at £310. If you look at it, you can see that it's half screen, half buttons, and made of plastic, with a speaker on the back of it. You also have the Pocket Talk S, retailing at £259, which is a similar sort of thing, a mechanical button, a screen, made of plastic. Finally, the same thing, in the lower range, you have the language translator, £87. Mechanical buttons, screen, made of plastic. All of these products and prices retrieved from Amazon.co.uk, and you can go and find them yourself if you just type in language translator. So I looked at the reviews and the parts that they're made of and how they're built, and I asked myself, what is wrong? Well, first of all, they're expensive. For £310, they're definitely overcharging their customers. When assessing the parts that's inside them and the language translation software that's available, £310 is definitely too much money to be paying for one of these. And it's definitely not worth paying when it's built from a weak material, meaning that it could just fall apart at any time. Mechanical buttons are unreliable, old-fashioned, get dirt underneath them, and break easy. And their single task, which is just kind of annoying for the consumer, considering that they have a processor, they have a screen, they have a microphone, a speaker, all of these other features, yet this only translates, doesn't do anything else that would help you in your everyday life since you'll be carrying it around with you all the time. It's not weather resistant, so really it's confined to being used indoors, which a lot of people who need to speak other languages are not always indoors. Sometimes they'll be in a refugee camp, sometimes they'll be on a sporting trip. And it's got a lack of usability. This means that it's made for professionals. It's not taking into account that some people might have learning difficulties, some people might be refugees, some people might be children, not professional translators who are using it to help themselves with their jobs. They might just be everyday people that just need a boost in their translating skills on the spot, not for any particular legal reason. Sometimes they might just want help with their day-to-day conversation making. So on a following note, I asked myself, what do we need in a better product? Something affordable, a strong frame, something that's not going to break, dependable controls, something like a touchscreen, a shatterproof touchscreen, not mechanical buttons. Additional features, because if you're going to pay money for something, you don't want it to do just one thing, ideally, when it has the hardware to do other things. Outdoor reliability, so that you don't have to worry about where you're taking it. It will perform the same in almost every environment. And user inclusivity, making sure that anybody can use this. So over the remainder of this presentation, I'll reveal to you how I came up with what you see in front of you. But for now, I introduce to you a new kind of portable translator device. To give you an idea of my design process, I've tidied up a few drawings that I did initially so that you can get an idea of the dimensions that I wanted to go for, the functions that I wanted to put into it, the materials that I wanted to make it from, the inputs and the outputs, the electrical components, every feature that I could think of that could feasibly fit into this device. I didn't want to hold back. It's designed with numerous extra features and a hard shell case. As you can see, I wanted it to withstand water, extreme temperatures, and shock. I also wanted it to be under £100, be affordable to the general consumer, someone who doesn't have a lot of money to spend on something that only does one thing. And I wanted it to be lightweight as possible. So based on the materials that it's made from and the size that I was going for, my goal weight was to be under 300 grams. So the mechanics were arguably the most important part of the design process for this product. The reason for this is because I wanted something that could be constructed to a strong standard, but then just as easily deconstructed either for repair or decommission. A lot of handheld devices, especially phones, have a lot of glue in them. Now when you glue two components together, two elements, for example metal and plastic, when you deconstruct that, it then becomes almost impossible to recycle those two elements individually. So my first construction feature was that I wanted to use minimal glue, instead utilizing aluminium clips. The only part of this product that uses glue is the silicone that's wrapped around the steel alloy frame. The frame is strong and will protect the components inside, and the use of silicone on the outside makes it shockproof. I wanted to use an acrylic screen and back because they're waterproof, compressed against internal rubber gaskets to make sure that no water can get inside. In this cross section of the whole frame, you can see that the clips push down inside the main frame and hold there, compressing the screen and the back against some gaskets that fit into the main frame. This design would hopefully stop any water from getting in the top or the bottom of the product. Next, I had to consider the electrical components of the device. I split my categories down to the computer, the power, the inputs, and the outputs. So starting with the computer, of course, I needed a development board with a processor and RAM. It's also Wi-Fi and Bluetooth enabled. It's dual core, runs at 160 megahertz in each core, and has 512 kilobytes of RAM. I need some hard storage, so I used a micro SD card reader with an 8 gigabyte micro SD card in there, and wiring to connect all of the components inside the whole thing together. The power is a 3.7 volt lithium ion rechargeable battery. The inputs are a 44 decibel miniature microphone, obviously to speak into in the translator, and 8 capacitive touch switches for the screen buttons. The outputs are a 95 decibel miniature speaker to speak the language back, a 3.5 millimeter aux jack socket so that you can use earphones on it, 2 LCD color displays, both 80 by 160 pixels, 5 millimeter white LED diode that you can use as a torch, and 8 LED pixel lights for the button luminosity. On this slide you can see how the product fits together. As you can see, when you remove the clip, you can remove the screen and the gasket. Then the top layer of electronics are removed. On the bottom, same thing. You remove the clip, then you can remove the back and the gasket. And then you can see the further electronics in there. All of these electronics are the right size so that you can see that they all fit inside. Currently, there's no frame that the electronics fit to. This is purely for an example to show that they can fit inside the main frame. Further development would be needed to be able to attach them to it.